I really want to pull out my whiteboard now.
Yeah. Now,
Okay.
let's get nerdy. Let's do it.
I like opening cans of worms and letting the comment section go wild. Hit me, Producer Potts.
Chocolate has lead, rice has arsenic, fish has mercury, and fruits and vegetables are sprayed with pesticides, organic or not. But thanks to you, we've all learned that these foods are still safe to eat. Can you please explain the phrase that you always use within the context of these videos called "the dose makes the poison"?
I would love to. I think this is such an important concept to understand, especially with how much fear there is around the presence of sometimes like pollutants and contaminants, and sometimes compounds that are inherent to foods. There's so much fear of these foods spread that are missing this really important concept in toxicology, which is the dose makes the poison. It is actually the fundamental, like underlying philosophy of the entire field of toxicology. And basically what it means is just because a harmful compound is present in a food, it doesn't mean that the amount that is present in that food is harmful in the quantities that you would normally consume. So understanding how this is determined, what a dose response is, what the acceptable daily intake level and or chronic reference dose is, I think is really helpful to being able to wrap our heads around. Just because insert big scary sounding name of compound, mercury, is in fish, it doesn't mean that the amount of mercury is anything we need to worry about. As I've already covered in previous videos, and I'm sure Producer Potts, you will put a link to all of those videos
Yes,
in this one so people can find them.
And I'll just say before we get started, like, it is very common on social media for someone to say, okay, I understand that these things only have small amounts, but like even in small amounts, arsenic is bad. And it's like, there is some sort of truth to that, right?
Yes. Okay. So I think actually, before I draw like a sample dose response and pull out the handy dandy whiteboard, let's actually add a second piece of like baseline information here, which
Okay.
is that our bodies have a whole variety of what are called detoxification processes. We have a lot of different ways that we can get rid of pollutants, even heavy metals. So I don't know that people know that we can actually, our livers can process and get rid of lead and arsenic and cadmium. We can get rid of mercury from our bodies in small enough amounts. So what we want is to be exposed to lower levels than what our body has the capacity to handle without it having any impact on our health. What we want to avoid is being exposed to higher levels than what our body can deal with. And that's where you see things like the water crisis in Flint, Michigan, where there was lead in the water. That was higher levels than what our bodies are able to detoxify. And that's why there was so much lead poisoning, right? So that is the situation where we want to avoid, right? We want to avoid exposure being higher than the level that our body's like, don't worry guys, I got this, I can detoxify this. And how like easy it is to get rid of something from our bodies is different depending on the thing we're talking about, right? So lots of fear about forever chemicals, right? Perfluoroalkyl substances, PFAS, I think that's what it stands for. But the reason for that is it has a very, very, very long half-life in our bodies, which means our bodies have a really hard time getting rid of it. Something like BPA in plastic has a half-life of 3 to 6 hours. Like our bodies are like, let's get rid of the BPA. I don't know offhand what the half-life is of something like lead or mercury, but I'm pulling these examples of something I do know as just kind of showing you like the difference between something that our bodies have a pretty easy time getting rid of versus something that our bodies just don't. Like we just, we don't have a bunch of different ways of getting rid of it, so it lasts in our body a lot longer. Maybe it's also something that doesn't break down down very well. So it also can last in our body a lot longer just because of the nature of the substance itself, in addition to how many different cool ways we have to get rid of it and process it in our bodies. So different substances have different amounts of dose that we need to worry about because of this, because different things are easier or harder for our body to process, detoxify, and get rid of. So that is another part of what goes into dose response. So we want to know, how harmful is the substance? What bad thing is it going to do, right? So different substances are differently toxic in different high amounts. We want to know how easy it is for our body to get rid of it. And then we want to know how much is in the food. So these are really important data points to understand, do we need to worry about the mercury in seafood, and what seafood, right? So we sort of talked about high, like top predator fish, like pilot whale, swordfish, depending on the water. There's mixed data on swordfish as having been exposed to more level of mercury due to bioaccumulation in aquatic environments. Then they have selenium, which is really important for how our bodies can get rid of it, right? So,
right. Yeah, you've talked about that.
This is a good example, sort of understanding that that's why we don't have the same dose for everything, right? That's why each thing has its own acceptable daily intake, which is the amount that we can be exposed to every single day for our entire lives without it causing any health harm, and or chronic reference dose, which is the amount that we're exposed to every single day in order to hit chronic toxicity, which are two sides of the same coin. They're different ways of measuring the same thing. How much can I be exposed to every single day before that amount is a problem, right? Before that causes me to be sick. And so in toxicology, we also have acute toxicity and chronic toxicity. We're talking about chronic toxicity right now. We're talking about how much every single day before that exposure over weeks to months causes some kind of health harm.
Right.
Acute toxicity, it's usually a much higher dose, right? How much all at once for that to be problematic. We're not really worried. I mean, we don't want to ignore that. That's still important information for all of these different things. But that we're talking about like poisoning. What, in the context of, being worried about pesticide,
the lead in our chocolate,
the lead in our chocolate, right? That we're talking about chronic toxicity.
Okay.
So we're talking about how much every single day.
I just have one other thing that I think I've heard you talk about before on other podcasts. I think is like helpful as we approach this subject is, there are things that are in foods because of like there are environmental toxins that we have. And you have talked on another podcast that it's really important that we do eat a nutrient focused diet so that we're getting all the nutrients our bodies need, because all those processes that you talked about, our body needs nutrients to perform them. So if we want our bodies to do that work for us, that's why it's important to eat a very nutrient focused diet. But if we're avoiding all these foods because they have toxins, we're still going to be exposed to some other environmental toxins. I think I remember you saying we get exposed to more heavy metals just walking down a city street than we do from, our chocolate bar. So like, if we're avoiding foods and being very restrictive and stressing ourselves out about, I can't eat this, I can't eat this, I can't eat this, we're not giving our body enough nutrients, and we're stressing ourselves out, meaning that we can't handle the environmental toxins. So it seems like it's just, you said it like a snowball of badness. So it's better to understand all these things you're about to teach us and move forward with that versus moving forward with fear. Yeah.
100%. I could not agree more strongly. So fun fact, one of the reasons why liver is such a nutrient dense food is because our livers, we're not eating human liver here. We're eating livers, mammalian livers.
From animals.
Mammalian livers, including ours, they don't store toxins. They're it's sort of a myth that you shouldn't eat liver because it's full of toxins. There are a few livers that we don't want to eat, but because they have so much nutrients, they can actually cause hypervitaminosis A, which is like vitamin A toxicity. But out of the types of liver you can get at the grocery store, you don't need to worry about that. The reason why it's so nutrient dense is because livers store all of the nutrients required for all of those detoxification processes. So a lot of those detoxification processes either require, well, they require multiple things. They require enzymes that need different nutrients to do their job. But then also there's a lot of nutrients that our livers like stick onto various toxins to render them inactive, and or to render them fat soluble or water soluble, depending on where they're going. So if they're water soluble, they go to the kidneys and then they're sent down that route. And if they're fat soluble, they're sent to our gallbladders and they're excreted with bile into our digestive tracts and go out the other excretion route. So that's actually why our liver is such a nutrient dense food, is because it stores all of the things that our livers need for detoxification processes. So we can get those nutrients from other foods. I'm not saying we have to eat liver, but like just as a fun fact, yes, making sure that we are getting all of the nutrients our bodies need from the foods we eat is really important for supporting all of our detoxification processes.
I love that. I love that so much. When you talked about that on a podcast, I was like, oh, that makes so much sense because we can't escape environmental toxins, especially, we all live in the zip code we live in. Most of us don't have the luxury to choose that, we are where we are in life. And, also, there is stuff in our food and, we do have to be mindful of how much, and like, we can't escape that. Sure. Could you move out into the middle of nowhere and grow your own food and do that? Yeah. But the majority of us don't have the luxury to do that. So let's just be realistic.
Yeah. So, also, I think the bigger point you're getting at is that pollution is a problem, and we do still want to find solutions to pollution. We still want to be enacting policies and regulations, and where possible cleanup efforts to reduce the number of contaminants that can potentially reach the food supply.
Right.
And we want to support ongoing biomonitoring studies, which are extensive, that are keeping an eye on these pollutants to making sure that we never hit a time where the mercury in seafood is higher than the selenium and then we need to worry about, or the pesticide residues in conventionally grown fruits and vegetables is high enough that we need to worry about. Right now,
and if that was the case, there would be public health warnings about that.
Yes, absolutely. Yes.
Yeah.
But
okay. Sorry, I sidetracked you a lot, but I remember you talking about that on a podcast, and that was very eye-opening for me and made me feel less worried about the small amount of lead in my chocolate. If I'm eating a really nutrient dense diet, I'm giving my body everything it needs to take care of that for me.
Absolutely. And it's also, worth throwing in a little extra nuance, because I think that is a really important thing when we're talking about nutrition and health related topics. So often these things are presented as black or white, or worse than that, they're presented as be terrified by my thing, right? I think it's really important to also understand that some people might have health conditions or genetics that mean that they don't detoxify certain substances as effectively as the average human. So there are also people who, may find that they do need something a little bit different. And so also acknowledging that there may be people out there who, their doctor has said, I really need you to eat this, or this because of this, or this. Your doctor's advice always trumps whatever science I have to share. So, also throwing that little bit of nuance in there that we are talking about studies that look at averages, and not everyone is well represented by the average.
Gotcha.
All right. I really want to pull up my whiteboard now.
Yeah. Now, okay. Let's get nerdy. Let's do it.
All right. So we're going to draw a standard dose response curve. So on the y-axis, we have badness. Whatever badness the toxin causes, okay? So higher up this way, more badness. Down here along this way, no badness, okay?
Gotcha.
And then here we're gonna have we'll say toxin.
The toxin.
Okay? Toxin, right? So over here is 0, right? That's 0. And then here is lots. And this is super bad. Okay.
I love this. This is
All
so
right.
simple. Yeah, super bad.
So most, I want to change colors. Hang on. I got to change colors. I don't actually know if this is going to be a different color. So most dose responses kind of look like this. This blue looks exactly the same. All right. Most blue is exactly the same blue.
It's okay. We get what you're doing.
I was so excited about having a different color to show. So most dose responses kind of look like, I don't know, it's like a drunk S, right?
Yeah, I got
Okay. So we've got a certain amount where then nothing happens, and then bad stuff starts to happen, and then bad stuff like super accelerates, and then there's like just a certain amount up here that's like it's super bad, right? So maybe it's
right.
Maybe it's dead, right? So up here, 100% of the bad things are happening. Doesn't matter if you add more of toxin, 100% of the bad things are happening. Okay.
Gotcha.
So we have some different little levels here that we like. So this is, we're measuring the more of this toxin we add, how much bad stuff happens. And so there's something here. This is called the LD50. So this is the dose at which half of the bad things happen. Like half of the, let's say the super bad thing is death, because often we're talking about a toxin where that's the case. This is the dose where 50% of all the bad things are happening. So we're like, oh yeah, that's the LD50 right there.
Gotcha.
So that is one important thing that not super relevant to us talking about like the lead and cadmium in chocolate, but is relevant for toxicologists, right? So they're like, yeah, there's that bad thing. Then there's like, you see how here where things are just starting to come up? This right here is called the lowest observed adverse effect level, or a low whale. I don't know. I don't know if, hey, toxicologists studying this, how do you short form that? Do you actually say Lowell, or LO?
Let us know in the comments.
Let us know. Let us know if you pronounce that in a way. So this is, where we know for sure if you're exposed to this much toxin, we can actually measure, right? We're measuring, that is a certain amount of badness, right? So if you're exposed to this much, and again, we're looking at chronic toxicity, so every single day for weeks to months.
Right.
Lowest observed adverse effect level. So at that dose, yeah, we know bad things happen. And then somewhere around here, this is the no observed adverse effect level, right?
Where we see nothing.
There's nothing.
Right.
There's nothing. Like that is
meaning, so
badness.
Just to clarify, is that meaning like, is that nothing like nothing, no matter if we're giving our body everything it needs to detoxify, or that's like nothing, even if we're eating like a crap diet? Does that make sense? Am I confusing things?
Look, I mean, our bodies are really resilient. We can detoxify even if we're not giving it everything it needs. Like,
okay,
our liver still do stuff, like as long as you don't have liver disease, right? Like,
gotcha.
Yeah,
it's still doing okay.
Yeah,
I see what you're saying. Okay,
a lot of these dose responses are established in rodent studies, right? So we don't give people this and see when half of them die, right?
Right.
So, and then human studies are all done in these lower levels if they are done, right? So,
gotcha.
So yeah, but still we're looking at averages. So we're looking at lots of data points going into this. Okay.
Gotcha.
So, no adverse, I don't know. Toxicologists, again, please weigh in. The no observed adverse effect level means zero badness. Okay. So that's the maximum amount at which there's zero badness.
And we're talking about how much every single day for either weeks to months.
This is a dose response for chronic toxicity. We have a couple of really interesting levels that are set based on the no observed adverse effect level. So we have something called the chronic reference dose, and we have something called the acceptable daily intake.
Okay.
Okay. So chronic reference dose basically refers to, it's usually an amount less. It's either at the no observed adverse effect level or it's an amount less, right? So we like divide it in half or divide it by 10 for safety, right?
For a buffer.
For a buffer. And
Okay.
that is like considered how much is above which you need to be worried about and below which you need to not worry.
Gotcha.
Acceptable daily intake level is also set, but it is always set based on applying a safety factor on the no observed adverse effect level. So we divide by a safety factor. That safety factor is typically 10 to 1,000. Sometimes it's more. And that safety factors, we set a chronic reference dose for things that are pollutants, right? That are toxins, and that are things that we don't have, like we've got this dose response, but we don't have a giant breadth of scientific evidence to support each stop. So it's a little bit fuzzy.
Gotcha.
We set an
So
acceptable
it builds
daily,
in even more safety then.
so an acceptable daily intake is set for things like preservatives, additives, right? Food dyes. Actually, fun fact, MSG doesn't have one because it's so safe. Topic for another video.
Oh boy.
Right. Just, I like opening cans of worms and letting the comment section go wild. So ADIs are set for, aspartame, right? So compounds that are used in food that we know that too much could, then cause cancer or cause some kind of problem, right?
Right.
So we have chronic reference doses for things like arsenic. We have ADIs for things like food dyes. So that is like, but they're basically the same thing. So they're both ways of measuring how much is okay to be exposed to in the food supply. Chronic reference dose would also include other sources of exposure. ADI is very specifically to the food supply, right?
Gotcha.
So, but they're both trying to understand this level, the no observed adverse effect level, and then trying to apply some kind of safety factor, which then, right, that safety factor is your buffer for not everyone being well represented by the average, right?
Right.
And so how aggressive that safety factor is in part determined by how steep this part of the dose response is. So if it's very steep, if things get nasty quickly, we're going to have a higher safety factor.
Gotcha. And
it also is set based on how much data we have. So if it's a little bit fuzzy and we're not entirely sure, bigger safety factor.
Yeah. Okay. So now that we have a clear understanding of this, of the terms, and kind of we can see that on the chart.
Yeah.
Can I ask you to do something else for us? And it's okay if
yes,
you don't want
please.
to. So we all love our chocolate.
Yes.
And we've all heard there's lead in chocolate, which I know you've covered, I think, on your TikTok and Instagram. We haven't covered it here on YouTube. Can you show us kind of how that would play out in a practical sense with something like chocolate that we all love? Can you show us what that would look like?
Yeah, let me pull some numbers for you.
Okay, great.
Okay, so for lead, the chronic reference dose for adults is 0.16 micrograms per kilogram body weight. So that is the chronic reference dose for lead. So I've got a 2018 study that measured cadmium and lead contamination in chocolate samples from a grocery store. They looked at 144 different samples. The average lead detected in chocolate was 0.03 milligrams per kilogram. So a milligram is 1,000 times more than a microgram. And so if you do the math with a 70 kilogram adult, which is our average 154 pound adult that we do typically for all of this, in the dark chocolate, which had the highest amount of lead, There was less in milk chocolate. You would need to consume 13 ounces per day, just 370 grams, every single day of dark chocolate in order for that lead to hit the chronic reference dose. So
And like, how
13
much is
ounces
like
is
is that like a big chocolate bar a day?
that's like so chocolate bars are typically 3 ounces. Um,
Oh,
yeah, so those
oh,
like big lint bars might be 4. So that's 3 or 4 of those big,
every single day.
yes, of dark chocolate, which has more lead in it than milk chocolate. Granted, also has more health benefits because of all of the polyphenols and
Right.
magnesium and chromium. Every single day. So
So our little square of dark chocolate that
yeah,
most of us have,
or your entire bar.
or you can have an entire
Yeah,
bar. I
or
mean,
2.
or two before you would even get even close
Yeah,
because
every
that
single day for weeks to months.
right, because that limit is set way lower than the actual harmful limit
Yeah.
anyways.
And for pesticides, and I know we've been meaning to do a whole video going through this, so
Which
like
we will.
opening the can of worms again. The pesticide residues on fruits and vegetables are 1 million times lower than the
I
chronic
can't wait
reference
to do that video.
levels that we
Yeah.
need to worry about. So, yeah. So, like, look,
So
right
breathe
now,
easy, everybody.
yeah,
Just
eating
relax.
a
Enjoy your food.
diverse diet, eat lots of different foods. That helps to get the full range of nutrients and also helps to protect against things like contaminants and pollutants, right? Because we're eating a wider variety. It's good for both of those. But there is not a single food where I would say be afraid of. Like all foods can fit into an overall healthy diet, and diversity is the key.
Right. I love that. Thanks so much, Dr. Sarah.
Thank you.